The U.S. released hundreds of giant beavers into the dry Utah desert with no water, and something unbelievable happened. The U.S. government, through a research project led by scientists in Texas, released hundreds of very large beavers into a dry part of the Utah desert. The area had almost no water. Scientists wanted to see what happens when a species that needs water faces extreme dryness. The release sites were old river channels, now cracked and bare, with only a few shrubs and endless heat. Over 400 beavers were brought from rivers in the Pacific Northwest. They were bigger than normal beavers, chosen to test their size and behavior. Each beaver was checked, measured, and fitted with a tracker before being set loose. No water was added to the area. Once released, the beavers began to spread. Some followed the empty channels. Others tested the soil or chewed on shrubs. A few dragged branches, acting on instinct. Cameras and trackers showed they moved mainly in cooler hours and stayed still when the sun was high. The first 3 days revealed how quickly the animals recognized the challenge. Nearly a third traveled several kilometers from their release points in search of shade, moisture, or plant material. Others stayed clustered in shallow depressions where faint traces of runoff lingered. Dr. Emma Doden, a Utah-based ecologist involved in the project, later explained, "A few of these beavers stuck where we put them, and even the ones that didn't," he also said. "They are probably still helping the system, as the river is so degraded." By the end of the first week, losses became visible. Several beavers died from heat exposure or dehydration, while weakened animals were targeted by desert predators. Despite this, survivors adjusted their routines. Activity shifted almost entirely to nighttime, and small groups formed around shaded rock walls and low ground. Instead of traditional lodges, some animals piled sand, mud, and branches into low barriers across dry channels. 2 weeks into the experiment, researchers recorded 17 of these rough structures. While they could not hold flowing water, a few trapped shallow puddles after rare rainfall. Julie Young, a lead ecology researcher monitoring the site, said, "We had more dams after our study than there were before our study. Even these small changes slowed runoff and collected debris, drawing insects and small animals into areas that had previously been barren." As monitoring continued, researchers noticed unexpected movement patterns. Several beavers traveled far beyond the release area, some covering more than 20 kilometers through canyon systems thought to be unsuitable for the species. A few disappeared from tracking altogether, likely due to predation or exhaustion. Scientists noted that these movement patterns differed sharply from beavers released into normal waterways. After 1 month, subtle changes appeared across the landscape. Shallow depressions held moisture slightly longer after rainfall, and vegetation near the makeshift dams remained greener than surrounding areas. Insects gathered there, followed by birds. During this phase, Dr. Doden explained standard handling procedures used during the study, stating, "Once a beaver is caught, it is placed in quarantine for 3 days before translocated, so it will not spread disease. The beaver is kept cool, well-fed, and close to water," and capped with saying, "Both the resident and translocated beavers in the study receive a radio transmitter and PT tag in their tail." By week 6, the population had dropped to about 40% of the original number. Deaths were linked to dehydration, exposure, and predators. Surviving beavers showed increased social behavior, often staying close together around shaded ground. Family groups released together showed slightly better survival rates. Cameras captured nighttime foraging, grooming, and repeated attempts to shape the land to their needs. At 2 months, signs of beaver activity stretched across multiple dry riverbeds. Small mounds, shallow ponds, and chewed vegetation dotted the terrain. Some tracked animals had moved more than 30 kilometers, showing that even under harsh conditions, exploratory behavior continued. By the end of 3 months, researchers concluded that while survival without water remained limited, the beavers altered the desert in measurable ways. Their digging loosened soil, slowed erosion, and gathered organic material. Julie Young later explained the broader importance of these efforts, saying, "That's why these dams are important, because it creates permanent puddles of water for the fish to take refuge during those times," noting that under less extreme conditions, even minimal structures could support wider ecological change.